Hello! In this video we'll be talking about section 1.1, graphs. Specifically, we'll be going through a couple more problems concerning equations and how to graph them. We will also be talking about a couple definitions as well. Our problem number 3 here says, find the intercepts of 3x plus 2y equals negative 18 and use them to graph the function. As we talked about in a previous video, the intercepts refer to the places where the line intersects or goes through the x and y axes. To find that, we're going to keep in mind that if you're going through, for example, the x-axis here, that means that your y-coordinate there must equal 0. So to find the x-intercepts, we are going to plug in y equals 0. So for the x-intercepts, we will plug in y equals 0 and see what we get from there. If I do that for my equation, 3x plus 2y equals negative 18. Plug in 0 for y, I will get 3x plus 2 times 0 equals negative 18. Intercepts tend to be very convenient to solve for because when you plug in 0, 2 times 0 here will just nullify out and make 0. So that means we get 3x plus 0 equals negative 18. The only thing left in terms of trying to get x by itself there would be to divide everything by 3. And that would give me x on the left. And negative 18 divided by 3 will give us negative 6. If we plot this point, we have the coordinate negative 6 for x, y for 0. So that would be back 6 on the x-axis. And on the axis, we're not going up or down any. Y-coordinate would be 0, so we get that point right there. To find the y-intercept then, we're going to do the opposite. To find the y-intercept where we intersect the y-axis here, x should be 0. So we're going to plug in x equals 0 into the equation provided. If we do that, 3x plus 2y equals negative 18. I can plug in 0 for x, so 3 times 0 plus 2y equals negative 18. 3 times 0 again is just going to nullify out, and that will just give us 2y on the left side equals negative 18. And like before, to get the variable by itself, we will then divide by this coefficient of 2. And that will give us y equals negative 18 divided by 2 is negative 9. Therefore, we have the coordinate x equals 0 and y equals negative 9. So 0, negative 9 is an ordered pair. If we plot those, we're on the y-axis because x is 0, so we're not going horizontally at all. But we are going vertically a distance of negative 9, which would put our point about there. We can always plot more points if we would like to help make sure that this line is correct, but 2 points should be all you need, and these intercepts tend to be very convenient for that. Like that. That would be my equation of this line. Let's look at another problem here. This one says for each of these 4 parts, we're going to state whether the following are equations or expressions. So, for this first one here, we have 7 multiplied by the quantity x minus 6. In order to be an equation, this would have to involve an equal sign. We don't see that there, so this is just an expression. Whereas if we look at the second problem there, 4x minus 5 equals 8, that means we have 2 expressions, 4x minus 5, as well as the expression of 8. Those are equal to each other. Because there is an equation sign there, this is an equation itself. Next one, very similar. We have 14x plus 8 equals 2. That means we have the expression 14x plus 8. We have the expression of 2. Those are set equal to each other with an equal sign, so that is indeed an equation. And then for the last one, we have 4t plus 9. Notice there is no equal sign. This is just an expression combining multiple terms. That is it. To wrap this up, we have a couple definitions to talk about. A horizontal line is the graph of a linear equation of the form y equals a, where a is a real number. The graph will then cross the y-axis at the point 0, a. Whereas a vertical line is the graph of a linear equation of the form x equals b, again where b is a real number, some constant. The graph then crosses the x-axis at the point b, 0. These are some of the more simplistic graphs that we will see. They also are technically counted as one of the parent graphs we talked about in another video. But these are relatively simple. A graph y equals a would just mean that we have something that intersects at a, wherever that would be on your graph, and goes through that, just like so. Whereas when you have x equals b, that means that you have a graph that intersects at the point x equals b, wherever that might be, and we have a vertical line that then goes through that. These graphs act in this way even though there is only one variable, because when the other variable is not there, that implies the other variable could be anything. So when we have something like y equals a, that means y is always defined as a, but x could be defined as anything. There is no connection between x and y there. Likewise, when you have x equals b, this means x is always defined as b, but y could be anything. There is no defined connection between them. That should be it there. I hope this helped you understand some more examples and problems concerning graphing. Have a nice day.